Oh, hello guys, and welcome to this new session of Azure Power Lunch. One more time, this session is recorded and the recording will be placed on YouTube. If you don't want to be recorded, please feel free to drop now. Today's session is about Azure Durable Functions. My name is Ala Tadmouri. I'm a Cloud Solutions Architect. And the agenda at very high level, we'll be discussing durable functions. I'll show you a demo of that. Durable functions are just an extension of the regular Azure functions. So we'll look also briefly at what Azure functions are, the common challenges with regular functions, and why we need it. Sometimes we need durable functions. Functions in general are at the core of our serverless, Azure serverless offering. So we'll talk briefly about serverless also. So let's get started. So the main idea behind serverless is the abstraction of the infrastructure. So you don't need to worry about the underlying servers. You just deploy your code and Azure will make sure that your code runs. It will add instances, add or remove instances to match the demand, scale out, scale in. You don't need to worry about that. And you pay only for the execution. So only when your code runs, you don't. Otherwise, you don't pay anything. Actually, the first 1 million executions are free. So it's the closest you could get probably to a free running of code. You still have to pay a little for the storage where the files live, but generally speaking, this is probably the closest you could get to running code on a public cloud to free. So Azure, the regular functions, I'm not going to dwell much here. I want to talk about the durable functions, but functions were designed by initially, or the best use case for them is for event-driven tasks, as you know. So there is always a trigger for your function. The function is where you will deploy your code, and there is always a trigger, be it a timer or a message dropped in the queue. There is always a trigger that runs the code. So it's naturally an event-driven solution, and usually it has bindings to integrate it with other Azure functions. I want to show you actually this quickly because it highlights everything about functions. You see here in this example, there's a queue trigger, and you see there's a Cosmos DB binding. If you remember the old days, we used to initiate a client, configure the client to be able to write and read from queues, Cosmos DB blob. It's all with just decorating your class with these attributes now to do the binding or the triggers. So when Azure functions come to mind, I think triggers and bindings. Also, they were designed for, or they are best used for stateless tasks. So and actually, it's a good recommendation to build stateless for the cloud. You don't really need the extra complexity of managing the state unless you have to. So functions are great for stateless applications or solutions. But what happens if you really need a state? For example, if the input of one function depends on the output of another. So you have to have the state here. Managing that state with regular functions, it's possible, it's doable. We've done it, but it's complicated, or it could get complicated very fast. And here where durable functions come into place. So durable functions are just an extension of regular functions, but the highlight of them is that they are stateful. So here, like some scenarios that are very easy to do with durable functions. The example that I mentioned, chaining functions. So the output of function one becomes the input to the next function, and so on. Chaining state like this is very easy to do with stateful functions, with durable functions. also like a scenario like fanning out, fanning in pattern. So in regular functions, it was easy to fan out. Your function could trigger multiple functions, but fanning in was tricky because you needed to wait for all the functions. You needed to ensure that all functions completed successfully before you could act on the aggregate of those functions. And you could imagine scenarios where if one function failed, how would you know which instance failed, how to rerun it again, what you would do in these cases. It used to get tricky quite fast. Actually, let me show you just this fanning in, because I was really fascinated by how easy it is. This is I have the link there, and but the fan out, fan in pattern. See this line of code, task when all. That's it. Really, literally one line of code to fan in. This will ensure that all functions finished execution successfully, and then you could act on the result of all these functions. Here, like they are having the sum, the aggregate. Human interaction, also another interesting scenario where if you trigger a function, then it requires some human or service. It doesn't need to be human and to do some action before it continues. I have the link here for the rest of the patterns. We could come back to them. I want to make sure that we cover the demo. Let's move on. From this slide, just I want you to know that durable functions are not replacement for traditional functions. Actually, we could take this more generally to all Azure services. As you know, we have tens of services in Azure. One is not necessarily, generally speaking, is not a replacement for another. I think of them as like Lego building blocks. What could be a great service for a certain set of requirements might be an overkill for another set of requirements. So that leads to the golden rule of requirements first. I can't emphasize this enough. Spend some time defining your requirements before deciding on the technology stack. There's much about to say on this and why I'm saying it, but that could be a topic for a different day. But I put it in golden color here. It's the golden rule. If you want to have an elegant solution, spend some time with the requirements first, then go to solutioning. All right, back to the durable functions. So to have a durable function, you have to have at least three components. I put them here to highlight them before we go into the code, just so we could, you will be able to follow the code easier. The first component is the starter function. It's where the trigger sits, and what actually turns a regular function into a starter function is this attribute orchestration client. So this is otherwise a regular normal function. The interesting thing about it, of course, it has a trigger like a regular function. The interesting thing about it is the response type. You could return as like 200 OK status result, but this actually starter function, or when you declare it with that, you have access to returning a special response that gives you back URLs to control the orchestrator, to see the status of the orchestrator, where it is actually, like, even terminate the orchestrator function. So remember, this status result is very interesting, and we'll look at it in the code. The second component of durable functions is the orchestrator, and what turns a normal regular function into an orchestrator function is this orchestration context trigger. The interesting thing about this is it has some code constraints. I put a link for all the code constraints at the very end of the slides. I'll show you that later on. But the main concept here is that your code should be deterministic, and that makes sense if you understand how the orchestrator function works. When the starter function triggers the orchestrator starts the first activity function, and then it goes to sleep. And then when the activity function finishes the execution, it wakes up the orchestrator again. So when the orchestrator wakes up, if your code is not deterministic, it runs again from the beginning. And if it sees that, if it finds itself in a different state, for example, if you here you have some code that generates random numbers. Before it went to sleep, you generated a number. It ran again the second time. It found a different number. It doesn't know what to do with it. So that's why you have these code constraints here. The activity function is where your code goes. This is just the normal Azure function. It's just decorated with an activity trigger. There's nothing at all special about this. It's where your code goes. And you typically, of course, if you have an orchestrator and you're going the durable function route, then most likely you have more than one activity function. Now, we are talking durable functions. They are stateful. Then, if you're wondering where this state is saved and how and behind the scenes, is actually it just uses the good old storage behind the scenes, the tables and queues to do the orchestration. I'll show you that quickly, and I added some like additional reading if you want on the orchestration behavior and how it saves the state, but you're not really required to know about this, and even is not a good practice to tamper with these manually, because you typically keep this to the orchestrator. It's interesting to look at them. However, if you want a deeper understanding of how durable functions work. Before we go to the demo, I'll show you just quickly here the code constraints. This is very interesting. I encourage you to look at it. Retry on failure, how to do retries from durable functions and how easy it is. The code I'm going to show you is in GitHub. You could clone it from here. And let's go to a demo. If you have any questions, please feel free to ask. And otherwise, I'm jumping into a demo. Please remember these three components: starter function, orchestrator function, activity function. And here, if we go to the code, I map them to classes just like that: starter function, orchestrator function, and I have three activity functions. Okay, so I'll run it from locally, then I'll show it to you in Azure. Just I want to highlight a few things. I'll run it first just to show you the results. So I'll remove probably all the breakpoints. So the starter function, as we mentioned, it has that trigger on it. It's, as you can see, it's a durable client here. And this is the status result. Instead of returning just the regular 200 OK or OK result here, it could return this check status response, which is the interesting part about this starter function. All what I'm doing in this starter function, I'm reading a query string name, and I'm passing it to the orchestrator. As you can see, start new async, and this goes to the orchestrator. I'm passing this name. The orchestrator then just really simple triggering these three activity functions that I have here. So I mentioned the code constraints that you cannot put here, but it's generally a good practice to keep this orchestrator just short and sweet like this, just triggering the activities. If you find yourself putting a lot of business logic, it's probably good anyway to move them into activity function. So you could do here retry on errors. You could do simple try catch to do some cleanups, but generally you wouldn't want to put heavy business logic in this orchestrator here. So I'm passing first the query string parameter, that the value of that. I'm passing it to the first activity, and then each activity will run. I'm just logging or writing a message to the log and passing, and the orchestrator will just take the output of that and puts it into an input to the next function. So I'm chaining, you see, I'm chaining the output. I'm turning it into an input for a different, for the next function. Same here, this, see this output is an input for the third function. And then I'm returning all the outputs from the 3 functions. Let's put just one breaking point here, and let's run it, see it first all together, what does it do, and then we could run with breakpoints to inspect the behavior. So that's the URL to trigger the function. You could trigger it. It requires a name, as you saw in the code, so I'm passing that, and sure enough, it hit the starter function. I have the name here should be filled with the value that I passed, and it's gonna start the orchestrator. I'm gonna actually. So it started the orchestrator. The orchestrator should be starting the tasks, and then I show you the response type. So let's format this. This is just a JSON, but I'll format it. So this, as you could see, the response type returns a URL to terminate the orchestrator while it's working, but this a URL to pass event here, like this could be used to determine the approval when you saw that some functions you could pass status to it to decide on what to do with the functionality when we saw the pattern of human interaction. This URL allows you to do that. But the interesting that I want to show you is this URL that allows you to check the status of the orchestrator and what it's doing. So apparently it completed. Of course, I'm not doing much here. I'm just writing to the logs. So it's expected to have complete by now. And the output that I'm returning is just, you see the output of this became an input. Output became an input to the next function and so forth. Now let's run it again with some breakpoints, because I want to show you one thing interesting that might throw you off if you try the code. Let's put breakpoint here and all these activities, and also inside the activities, I'll put breakpoints. Are you with me so far? Still? I promise we'll go to Azure. Just let's look at this quickly. It's really important. So let's trigger it again. Nothing new. Started the function actually. Give us the status, triggered the. So here at the orchestrator, as expected, it came to the first here line of code. It will start the activities. Gonna hit continue. It will go to the first activity. Still, that's what we expected to do. Now, when I hit continue, I should have. Did you pay attention what happened here? When I hit continue, you would probably expect it to go to function 2 right away, but it went from the beginning. But now, when I click continue, what do you think it's going to happen? I probably think it's going to call the activity 1 again, but it doesn't. See, it went to activity 2. So the reason behind that is the way orchestrator, as I mentioned before, it triggers the activity and then it goes back to sleep. When it wakes up, it doesn't continue from step 2 as I expected it to do. It will actually start from the beginning. It will look at this task. It will look at the underlying storage, because it's tracking the state. It will see that it triggered this function already, so it will take the result of it. It will not run it again, and then it will move on. That's why the code should be deterministic, the previous thing that we discussed. So here now it's gonna trigger activity 2. And indeed it went to activity 2. Now again here, what do you think will happen when I hit continue? Right. You see, it didn't go to activity 3. It went from the beginning, but again, it will not run the activity. It just started from the beginning. It will not even run this activity. It's right away going to now to orchestrate or to run to trigger the third activity. Now it will run the third activity, and it will exit. It will start from the beginning, but it will see that it finished all of them, so it will not execute them again. But it's tracking the state, and it gave back the result. And of course, if we again copy this URL, it should tell us that it's completed. It's completed, and it gave us back all the results of the. Does that make sense? All right. So now I'll show it to you in Azure. If you go to Azure, you will not find something called durable functions, because as mentioned, durable functions are just an extension of regular functions. So if you want to create durable functions, you just create regular function app. So go ahead and create the. Just show you the creation. There's nothing at all special about creating durable function app. It's just a regular app and regular Azure resource. I'll put it in your resource group. Function app name. Okay, I'll deploy it as code. I'll choose .NET for the runtime. Here chose the latest. That's good. And the hosting, you would need a storage account, and this is where it holds, it puts the artifacts of the function, and also where it manages where it would put the state. So it would use the table storage, and so okay, I'm okay with this. Creating a new storage account. Windows is fine for me. The consumption plan, I'm good with that. This means just that you pay as the code runs, but you could also like purchase a dedicated, let's say, execution with app service plan. Monitoring, you could enable app insights. Is optional, but it's great, especially during if you want to debug these functions. Go and run it. That's it about running app. Now I've created an app already and deployed my code. So let's go to it and highlight some stuff in the time that we still have. So this is one I already created. As you could see, there's nothing special about it. It's an function app, storage account. And if you go to the function app, you go to functions, you see here nicely that Azure shows you that these the type of what type of function it is. So this is an activity, this is orchestration, and this is an HTTP, because I'm triggering this starter function with an HTTP request, as you saw. So some interesting things here to show is that probably there's a lot of interesting things actually about Azure Functions. The deployment center, I deployed from Visual Studio right away, but you could also very easily hook this function app to GitHub or Azure repos and deploy from your repository right away. Configuration is also interesting. If you have configuration in the app settings, you would need to go here and put these app settings. Visual Studio does that automatically. If you're deploying manually, you need to just port, of course, your settings to this settings here. That's for the sake of it. Let's go ahead and run it from Azure. Test and run. I'm passing, let's do it actually the same way we did it for. Nothing new, still same result here. And if I copy this URL, it should give us that, yeah, it's completed, and it ran actually faster than it ran locally, because so you see it's within the same second it finished, while and locally it took some seconds in between. But anyways, you could monitor the functions as you know here. Like it's showing me the runs. Let me show you also. If I go back to the resource group where the function is, let's look at the storage. And here, if we look at the storage explorer, look at the tables, and you see the history. See, these are all the orchestrator behind the scenes, how it knows what task completed, what task to start, etc. All of that is on these tables, and in the queue. We won't see anything in the queue because it already, of course, picked the tasks, but that's where you see them. So there's much to discuss. I put again some useful links for further readings. Unfortunately, we run out of time. With if you have questions, please feel free to ask. We still have a minute. Maybe I could answer a couple of questions. Otherwise, that's the demo of today.
I have a quick question.
Please.
Now that we have the state with the durable functions, is there anything that we should probably be considering when we choose between the Azure Batch and durable functions, or is there something there for like best practices, like when we recommend to the customers?
I would say the requirements, of course, per rule. So your requirements should define that. Durable functions are very good at resolving these the patterns that I showed here. So if you have a long running process, for example, you want to monitor, look at these fan out, fan in, human interaction. So those are perfect fit for durable functions. If you find that you are doing a slight modification to these patterns, go for it. If you find that it's an overload for these patterns, I wouldn't probably go the durable functions route. Again, the requirements is what informs the decision of the technology staff. If you have further questions, please feel free to reach out on Teams. Sorry, we ran out of time. Have a great day and see you next time.
Thank you, Ella.
Thank you, guys.